welcome back. So in our previous sections, we were talking about the makeup of the Earth's atmosphere. So the same way we talked about the makeup of the inside of the Earth, and then we talked about the structure of the inside of the Earth, and we said that the Earth had a solid core surrounded by a liquid outer core, surrounded by a mesosphere, surrounded by a asthenosphere, surrounded by a lithosphere. Well, we can do the same thing with the Earth's atmosphere. So let's start off with the layer of the Earth's atmosphere that is the closest to the ground, which is going to be called the troposphere. So the troposphere extends upward for, let's say roughly 10 kilometers and about 30,000 feet. So just roughly speaking. And you can basically know where the location of the troposphere is if you see a cloud. So Earth's weather takes place in the troposphere. And so I wanted to show you this picture here of, that's called an anvil cloud. And so you would find these if you went to Oklahoma or Texas or Kansas, where they have these very, very severe thunderstorms which can often generate tornadoes. So what has happened here is this is such a terrific storm. It has so much energy that the clouds have boiled up to the boundary between the troposphere and then the next layer above it, which is going to be called the stratosphere. And we're not going to get into it, but once clouds reach the stratosphere, they cannot go any higher. So they then go sideways. And the direction they go depends on which way the wind is blowing. So when the wind in this particular example is blowing to the left, and so it's causing that kind of an anvil type shape to it. Okay, so that is, and if you see one of those things, you better run for cover because there's going to be a very severe storm whenever that thing comes over. All right, so let's go back to the previous slide here. And so we said that the troposphere is the place where you're basically going to see clouds, and it's the place where Earth has most of its weather. All right, now let's go into the stratosphere. And the stratosphere is going to be where you're going to find ozone. So regular oxygen, the stuff that we breathe, is O2. So it's going to be O2. But ozone is going to be O3. So it's going to be three atoms of oxygen that have been put together to make one molecule of ozone. So the stratosphere is going to be very important because it's going to act as a shield against ultraviolet light. And if it wasn't for this stuff, that most of that ultraviolet light would make it through to the surface, and then we would have a lot more skin cancers and cataracts as a result of that. So we'll talk about the stratosphere in more detail in just a moment. Now the next layer above that is going to be called the mesosphere, which is actually very unfortunate because you've heard the word mesosphere before. So that was the middle, so that's what meso stands for, middle layer of the Earth. So you had the inner core, the outer core, the mesosphere. That was the part that was convecting, and it caused the plates to move. So the Earth also has a layer that's going to be called the mesosphere, and we're not going to be so interested in it. Then let's go up to the next layer, which is going to be called the thermosphere. Thermo means hot, so that means that this particular area of the Earth's atmosphere is going to be hotter than what the mesosphere was. And again, we're not really going to get into it. Although you should notice that the aurora, the northern lights and the southern lights, the aurora borealis, that's where you see them. So you're seeing light that is being generated in that part of our atmosphere. And then you have the exosphere. So the exosphere goes all the way up until it basically peters out into outer space. So like 500 miles up into the air. So that's the exosphere. So those are the various layers of the Earth's atmosphere. But if you combine the exosphere and then the thermosphere together, you get what's referred to as the ionosphere. And I did want to mention that. So what do you think is going on in the ionosphere? Well, the key word is ion. And in an ion, you have an atom where the electrons get knocked off, and then you have ionized it. You have an electrically charged atom when that happens. So what happens up there is you have a lot of oxygen and nitrogen, not a whole lot of it, but those are the elements that are up there. And then when they get hit by gamma rays and X rays, it ionizes those atoms. So the ionosphere is very important because it protects us against the hard radiation that is coming in from the sun. So the X rays and the gamma rays. It's the stratosphere that protects us against the softer radiation like the ultraviolet. So without our atmosphere, we would basically be cooked by all of this radiation that's coming in. Well, whenever you ionize an atom, then and electrons reattach back to the atom, then it gives off light. And so this is the origin of the auroras. So when those atoms are ionized by the radiation, but then they return back to normal, they give off light. And that's the source of the auroras. Okay, so we're going to take a break. And when we come back, I want to talk about exactly how does the stratosphere protect us against ultraviolet radiation. So I'll be right back.